So 15.8, sample spaces, and then also events. So if you have a random experiment could be simply, we'll talk about probability later, but a sample, a random experiment would be like flipping a coin, right? It's random. So when we flip the coin, it's a random experiment. Could be heads, could be tails. Now I think I looked up, was that in here we looked up? Yeah. Supposedly it's like 51%. If it starts on heads, 51% chance of end on heads. So maybe not completely equal, if you will, but it's still random. It's still a random event. So you have a random experiment, and then in that, the set of all possible outcomes in the experiment would be the sample space. And so flipping a heads, that's the experiment is flipping the heads. Flipping a coin is the experiment. And so flipping the coin is the experiment, and then the sample space would be you're getting either heads or you're getting tails out of that. So that would be the experiment is flipping the coin, the sample space is getting the heads or tails. Now, any subset of the sample space is called an event. And so in this case, so the event is, right, you are getting a heads or a tails, and then maybe, or you could also, these notational things are not important, or that important, I should say. So you could also write as heads, tails is the, the sample space. I wrote event because I was going to talk about that. So this is your sample space, okay? And so in the sample space, you have heads, tails, or you can write it as heads, tails. An event is pretty easy with a coin. You're either going to get heads, that's the event, you get heads, or the event that you get a tails. Now, if it's a singular outcome for the event, then it's called a simple event. So the simple event, in this case, is both of them heads or tails. Now, if we did a different example for this, we'll keep the words up there, sample space, event, and then simple event. That would be, what if you're rolling a die? So if you're rolling a die, what is your sample space for rolling a traditional die? 6 outcomes, right? So 1, 2, 3, 4, 5, and then 6. Now in this, the event, you actually can choose a few different options. You can say, what is the event that you get even numbers? What is the event you get odd numbers? What is the event that it's greater than 4? What's the event that it's 1, 2, 3, 4, 5, or 6? Like individual ones. So in this case, like with the flipping the coin, you either get heads or tails, there's no other options. But with the events here, you could say the events of evens, you know. You could say the event is an odd. You could say the event is the numbers greater than 4, which would just be 5 and 6, right? You could say the event for the numbers less than 5, so 4 on down. You could, right, and the list would go on, not infinitely, but you could come up with a lot of different possibilities of what you're looking for in that random experiment. With that, none of these that I just listed would be considered simple events because none of them have an outcome of 1. That's, you know, there's 2 options here, 3 options here, 3 options here, 4 options here, so none of those are considered simple events. They're just the event of something happening. So that's where you might see some terminology for that. Okay, rolling a die, or rolling 2 die. On page 743, they give you this chart here. You know, there's nothing to memorize in the chart. All it is 1, 1, 2, and they use actually red die and blue die, so I might be able to do that too. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Just make a note of it, and then they have a dot there, right? A dot. I think they have dots on this as representation for possible outcomes. And so with this, so on and so forth, all they're representing is that when you roll 2 die, if you count all the dots, there's actually 36 possible outcomes when you roll 2 die. So it could be 1 on the red, a 1 on the blue, 1 on the red, a 2 on the blue, so on and so forth. So when we deal with probability and they say, hey, you're rolling 2 die, what's the probability of something? You know there's 36 outcomes. That's why I'm going to reference this is looking at, that gets commonly used in mathematics. So you're rolling 2 die, what's the possibilities that you'd end up with, whatever, a set of even numbers or whatever. And when you're dealing with probability, you know there's 36 total outcomes when you roll 2 die for that. So then, yes, go on.
So say if we have a hypothetical where if we have 3-sided dice and on 2 sides.
3-sided dice. Yep, like a triangular die.
And on 2 sides we have a 1, and on another side we have a 2. Would that change like the amount of numbers in the pool for like to be 1, 1, 2, or just 1 and 2?
Yeah, it'd just be 1 and 2 unless there was a distinguishing factor, like in which case it'd basically be a different number. But like it's a red 1 and a blue 1, and then the number 2. In which case they're 2 different ones. But if it's just 1, 1, and 2, then you're rolling. It's like, oh, I got a 1. Well, it doesn't matter which one, depending, what the game is. But yeah, then it would just be 1 and 2 are your possible outcomes, unless you distinguish between the ones. In which case it'd be like a different number, I guess. Yeah, so good question there. So if we go to page 744, I'm not going to, there's a fair amount of writing, so it'll be a little cumbersome. Writing, you gotta list a bunch of numbers, but you guys will get it done in class today. So, but let's go look at number 1. It says, refer to the 2 dice experiment described for 1 through 6 and specify each event. So you are not coming up with, you're not picking the event. Like here, I just picked a handful of different events that it could have been. They're going to specify for you, and then you're going to write down what the event is. So they're going to say, hey, write out the event, specify the event. So when it says both both dice show the same number, what they want you to do for number 1 is, they want you to write out the event that both dice show the same number. So the event is going to be this. It's going to be 1, 1, right? And then what's the next one going to be? 2, 2. Now I'm putting squigglies. You could, I think they may actually just have parentheses, which looks like it doesn't matter. Somebody, probably to the true mathematician, which we all are, but we're okay with a little bit of adjustment. It may be better to say something like this, like brackets, and then the parentheses represent the event. But you're not going to get marked wrong if you put brackets instead of parentheses or vice versa. Not important. So 1, 1, 2, 2, and then what is it going to be? 3, 3, and then 4, 4, 5, 5, 6, 6. That's it. Okay? So that's like all you would have to do on number 1. Number 2, the sum of the numbers showing on the 2 dice is 6. So the sum of the 2 numbers is 6. So when you think about this one, give me an option for the sum is 6. 1 and 5.
5 and 1.
3, 3, and then that's what I was kind of looking for, Miles. What? 5, 1. The reason I'm looking for that too is just to help you understand, right, that when you go to roll that die, your red die is 1, your blue die is 5, but you also could have the blue die being 1 and the red die being 5, or vice versa. So you would need to include both options. Even though 1 and 5 are the same number, it depends on which order they are, 5 and 1 or 1 and 5. So if you're ever playing like Settlers of Catan, you ever play Settlers of Catan? Yes, right? It's been a while, but they have, if you remember, the numbers that occur the most and that occur the least. And you're rolling 2 die on there, and I think certain cards have like a 1. The number 12 has like a 1 dot on it. Yeah, it's the probability, meaning 12 is the least likely outcome when you roll 2 die. And then the number 1, when you're rolling the 2 die, is actually non-existent because you can't get it, right? So that's not there, but 2 has a 1 on it. And then 3, I don't know what the dot, maybe they have 2 dots on the 3. It's not exact probability because I think maybe even on the 4 they have 2 dots, possibly, but you can look. But that's just representing in that game, Settlers of Catan, like, meaning the least probability, they just put a dot, one dot, but as the probability goes up that you're going to get more options to get a 4 out when you roll 2 die, they put more dots on it. And then 7 is the highest probability, and that one is the robber if you've played the game. So, but that's based off of this like that. Okay, so then you could cruise up. You can keep doing that. If you go to number 7, let's look at 7 together. And then it says 2 bags contain marbles. The first bag contains a red and a blue. The second bag contains a red, blue, and yellow, and green. 1 marble is drawn from each bag. Specify the sample space. Now the sample space is representing all, right? Go back up here. All of the possible outcomes. So when we're doing this, so what is it, 7a? So the sample space is all the possible outcomes. So when you think about this, the first bag has, you're going to draw 1 marble from each bag, right? So you're going to have how many marbles? 2. So you would just write, you'd probably write like that, right? And you're going to get, so the first option is, in it you have what, a red and a blue. So you go through and you say, okay, what if I pulled out a red? Great. And then the second bag, you have to start the options. What's the first one, maybe?
Red.
Red, so you could get out an RR. Or you could get out a red what? Blue, or you could get out a red yellow, or you could get out a red green? The red green show. Anybody watch the red green show? No. Oh, wow. You know, it's one of those shows that probably, I don't know if it's still around, but probably was a niche show that like my brother-in-law was into, and not many other people are. But I think he's a Canadian guy, and he has like a shop and fixes everything with like duct tape. It's not really a how-to, and he like has some comedy in there. I think it was on PBS maybe. You could look it up. I think it's probably appropriate if I had to guess. So the red green show. So red and then green, and then is there any other options for that?
Yes.
Red. Oh, then you do blue. Okay, I was saying for the reds. Is it red? No other reds?
That's it.
That's it, and then you would go blue, R, right? B, BY. So when I said there's a lot of writing, B green. So sorry about that. Actually, I'm not sorry. Do some work. You're fine. You're fine. It is a little cumbersome, but you'll be okay. Especially with like number 5. The product of the numbers showing the 2 dice is less than 10. No, that's okay. Okay, so it makes sense on that one. At least 1 red marble is drawn. Now remember on 7b, it says specify the event. So this is your sample space. So when you're doing B, you can't come up with anything different than what's in the sample space, right? So an event has to follow from a sample space. So, you know, it's like, hey, if my sample space was a heads and a tails, the event can't have something new. I guess you could say it's standing on edge, but they never considered that. But so on 7b, it says, specify the event that at least 1 red marble is drawn. You would just look up here and draw all the ones with at least 1 red. But what does at least mean? Can it have both?
Yeah.
Right? It can have both. So RR, RB, RY, RG, and then BR, and then those 5. Yeah.
So just list those 5.
Yeah, list those 5 for part B. Yeah, cool.
So, real quick, are we assuming that we're drawing like in order from the first bag, or is there any like specific order that we're drawing in? Because then that would mean that YR and GR and YB and GB would be possible outcomes.
Okay, so Cole's raising a good point. Since we just to kind of address that, we didn't address it, but we made a note of that with a die. So in this case, right, you say YB, but YB is the same thing as BY in this case because it's drawn out of the marble bag. So this is, these would be the same, just representing it in a different order, whereas this is different because it's a red die and a blue die, red die and a blue die. but this y is only coming out of the second bag. It can't be swapped in the first bag and mix and match the two wells.
So it's like the three-sided testing that we.
Yeah, I think so, yeah. So, but great question, do you need to list YB? No, you wouldn't list YB, you would just say BY. So you can think of it as first bag, second bag, first bag, second bag. But then here, you wouldn't be able to go first bag because there's no, Y in there. But you, like in this case, you wouldn't need to distinguish first bag, second bag, it would be fine. You wouldn't have to say this is the first bag and the second bag as I list them. So. Good question. Okay, so then 8 is red, blue, dire toss, RBG, represent each outcome.
We just had 1 through 7.
Now you only have to do what?
1 through 7.
Oh, wow, good. Let me briefly mention number 8 though. On 8 it says a red, blue, and green die are thrown, so you have 3 die being thrown. It says how many elements are in the sample space. So in that case on 8A, they actually don't want you to list all the sample space because otherwise you would be listing you'd have to go 1, 1, 1, right? 1, 1, 1, 2, 1, 1, 3, 1, 1, 4, then 1, 2, 1, 1, 2, right? So there'd be quite a few. So they're just asking how many total are there? They want you to think through that. So we know with 2 die, there's how many? 36. So with 3 die, what do you think?
Oh, you probably cube the number.
Yeah, cube the number. Nice. Yeah, so 6 cubed. What's 6 cubed give you? 216. Yeah, nice. Good. 216. So that would be the answer for that one. And then you could go from there, but you don't have to do number 8. Great. But that would be how you would do number 8. Okay, so we're going to stop there, finish that up. I'll get those answers to the, what do you want me to do with the answers for the MCA? You're going to post them on Google Classroom, just have them available here. You want me to print them off so you can look at them at the convenience of your own home?
Yes.
Okay,
Google Classroom.
print them off.